So far, we've used L'Hopital's rule in a couple different ways to evaluate limits that were in the form 0 over 0. Let's see that we can also use L'Hopital's rule in other indeterminate forms. So what happens if I ask for what's the limit as x goes to 0 from the right of x times natural log x? So note, the domain of natural log of x is positive values of x. So we want to make sure this isn't just limit x goes to 0. We want to make sure that x is going to 0 from the right, because otherwise natural log of x is undefined. So what happens right now, this is currently of the form x as x goes to 0 goes to 0. Natural log of x goes to minus infinity. And so we currently are at a 0 times minus infinity indeterminate form. So make sure, so there's a couple of things going on here. This doesn't fall into the cases that we originally had, but it is worth noting that this also does apply to one-sided limits as well. So yes, even though this is, we were writing this out for two-sided limits, everything on here and with the addendum about n plus or minus infinity does fall into place. We're talking about one-sided limits. So that's fine. However, so as I said right now, we've got 0 times infinity indeterminate form. That's not 0 over 0, or it's not infinity over infinity, but if we do a little bit of manipulation, we can get to something that looks like 0 over 0 or infinity over infinity. So here's the trick. This is a very common trick when dealing with L'Hopital's rule. What we're going to do is that instead of multiplying by x, we're going to divide by 1 over x. So if I asked you, if I said to you, let's look about if I said, think about natural log of x over 1 over x, you would probably instantly say, oh, we should flip this upstairs and say this is natural log x times x over 1, so that's x times natural log x. We're just doing that in reverse. So we are intentionally making this more complicated. We went from x times natural log of x to natural log x over x. Oh, sorry, not over x, over 1 over x. These two things are equal, so it looks like we're making this more complicated, but there's a reason for it. And the reason is, as x goes to 0 from the right, natural log of x is going to minus infinity. 1 over x is going to positive infinity. We're in an indeterminate form that now we can apply L'Hopital's rule to. That here is our upstairs function. Here's our downstairs function. We're just going to take the derivatives of the upstairs and downstairs functions separately. So let's do that. So the limit as x goes to 0 take the derivative of natural log of x. That's 1 over x. Take the derivative of 1 over x. That's minus 1 over x squared. So if we manipulate this, now we're going to flip this back upstairs, and we end up with minus x squared over x, which is the limit as x goes to 0 of minus x. And hey, that's 0. So what's the moral of the story here? If we've got an indeterminate form that's not 0 over 0 or infinity, make some change to it in order so that it is, or that we do get it to be something that is infinity or 0 over 0, and then apply L'Hopital's rule. Let me show one more example of this type. So how about we look at the limit as x goes to 0 of 1 over sine x minus 1 over x. So right now, as x goes to 0, sine x goes to 0, so 1 over 0, 1 over 0, those are both infinity. We're essentially at an infinity minus infinity indeterminate form. So once again, what do we have to do? We have an indeterminate form. We want to use L'Hopital's rule for it. We have to manipulate this so that we get a 0 over 0 or infinity indeterminate form. So whenever we see a difference of two fractions, we should think, let's put it over a common denominator. So what do we end up with? The denominator is x sine x. So cross multiplying, we end up with x minus sine x. So this is equal to this, and now we plug in 0. We get 0 minus 0 over 0 times 0. Now we're in the 0 over 0 indeterminate form. So hooray, after a little bit of manipulation, we can apply L'Hopital's rule. So L'Hopital's rule, take the derivative up here, 1 minus cosine x. Take the derivative of the downstairs. How are we going to do that? Product rule. So it's going to be 1 times the derivative of x, which is 1, times sine x, plus x times the derivative of sine x is cosine x. Now let's check to see what happens when we plug in 0. We get 1 minus cosine 0 is 1, over sine of 0 is 0, plus 0 times cosine of 0, that's 0. We're still in a 0 over 0 indeterminate form. So guess what? It's time for us to apply L'Hopital's rule again. So the derivative of the upstairs, 0, derivative of minus cosine x is sine x. Derivative of downstairs, derivative of sine x is cosine x. And then the derivative of x cosine x is going to be cosine x minus x sine x. Okay, so now we're at a place. Let's see what happens if we plug in 0 at this point. So sine of x is sine of 0 is 0. And then downstairs we've got cosine 0 is 1, cosine 0 is 1, minus 0. So look, we do have 0 over 2. So our final answer is 0. So what's the moral of the story from these two examples here? In this one, we had infinity minus infinity indeterminate form. In this one, we had a 0 times infinity indeterminate form. If you have something that's not a 0 over 0 or infinity indeterminate form, do some algebraic manipulations. So this kind of algebraic manipulation and this kind of algebraic manipulation to get into something that you can apply L'Hopital's rule to.